Drowning in dense research papers? Deep Dive is where two AIs break down academic and market research, so you don't have to. From quant finance to AI policy to economic models, we translate it, explain it, and deliver what matters. Like, share, subscribe. Knowledge should be accessible, not locked in PDFs. Fresh AI insights delivered regularly.
Ever feel like you're trying to understand today's economy by reading last month's newspaper?
Oh, absolutely. It's a constant battle, isn't it? Especially with things like global trade data.
Exactly. You hear about these big official numbers, but they often land weeks, even months late, like the Dutch CPB figures for world trade volume. They're like, what, 8 weeks behind?
Yeah, nearly 2 months. And think about that. Policymakers, businesses, anyone trying to make a smart decision now is working with seriously old information.
Like driving using only the rearview mirror.
Right.
Right. So this is where our deep dive comes in today. We're looking at how to get ahead of that lag.
We're talking about nowcasting. It sounds futuristic, but it's really about predicting the present, using the data we do have available right now to figure out what's likely happening before the official stats confirm it.
Right. And the mission today, to explore some really fascinating research that's using, well, huge data sets and pretty clever machine learning to try to give us that real-time picture.
These aren't just small tweaks. Some of these methods offer potentially massive shortcuts to understanding current trends, sometimes with surprising accuracy. It's about finding those early signals in all the noise.
Okay, let's start with that world trade problem. Why is that 8-week delay such a big deal? What does timely trade data actually tell us?
Well, think about it. World trade is kind of the engine room of the global economy, isn't it? How much stuff is moving around the planet tells you about demand, about supply chain health, overall economic momentum.
So if you're flying blind on that for 2 months,
Your decisions are based on potentially stale assumptions. Are consumers still buying? Are factories ramping up or down? That delay creates real uncertainty.
gotcha. So the first paper we looked at tackles this directly. They weren't happy just waiting.
Not at all. They figured, okay, the official volume data is slow, but there's loads of other information out there that comes out much faster.
Like what kind of info?
Things like shipping costs, port activity levels, even business surveys asking exporters about their order books. Stuff that might give you an early clue about trade flows.
Okay, makes sense. So they gather all these early clues.
And not just a few. Their big idea was to use a massive data set, get this, around 600 different variables.
600? Seriously? How on earth do you even manage that?
That's the challenge, right? And that's where machine learning enters the picture. Traditional economic models, they often struggle with that many variables and the, complex, messy relationships between them.
The real world isn't always neat lines on a graph.
Exactly. So this research explored different types of machine learning. Some more, let's say, traditional nonlinear methods, then things like random forests and gradient boosting, these tree-based approaches.
Okay.
And then some really interesting regression-based techniques, like something called macroeconomic random forest and linear gradient boosting.
And did they find a winner? Did one type of machine learning really shine?
They did, actually. It turns out those regression-based methods, the macroeconomic random forest and linear gradient boosting, they consistently did the best job at forecasting world trade.
Better than the others?
Yeah, better than the other machine learning types and better than the more traditional nonlinear statistical approaches they compared them against. It really suggests these specific ML tools might be uniquely suited for this kind of economic nowcasting.
Okay, but hang on. 600 variables. Even with fancy machine learning, you can't just throw everything into the pot and hope for the best, can you?
No, absolutely not. And that's actually the core contribution of this first paper. They came up with a really smart, flexible 3-step approach to make the most of both the huge data set and the machine learning.
A 3-step recipe for better forecasting. Okay, I'm intrigued. Lay it on us.
All right, step 1 is pre-selection. Basically, before you even let the main machine learning algorithm loose, you intelligently choose the most promising variables from that initial pool of 600.
How do you do that? How do you know which ones are promising?
They use some sophisticated statistical techniques, things called LARS, sure, independent screening, Bayesian model averaging, fancy names, but the goal is to identify the predictors that seem to have the strongest signal.
And did just doing that filtering help?
Massively. They found that this pre-selection step alone boosted the accuracy of their forecasts by about 10 to 15%.
Wow. Just by being smarter about the ingredients.
Yeah.
Okay, that's step 1. What's next?
Step 2 is factor extraction. So you've got your refined list of, say, the best 50 or 100 variables from step 1. Now, you try to summarize the core information in those variables into an even smaller set of underlying factors.
Factors, like the main driving forces behind all those individual numbers.
Exactly. They used a common technique called principal component analysis, or PCA, for this. Think of it like taking dozens of weather readings, temperature, humidity, wind speed, pressure, and summarizing them into just a couple of key indicators, like good weather factor or storing weather factor.
Okay, simplifying it down to the essence. And was that better than using all the individual selected variables?
Yes, that was a key finding. Using these extracted factors actually led to more accurate predictions than using all the individual variables, even the pre-selected ones. It helps filter out noise and focus on the bigger underlying patterns.
Right. So step 1, pick the best ingredients. Step 2, distill them down. What's the final step?
Step 3 is the machine learning regression itself. You take those condensed factors from step 2, and now you apply your chosen machine learning technique, like that macroeconomic random forest they found, worked so well to generate the actual forecast for world trade volume.
Ah, okay. So the machine learning works on the refined, summarized information, not the raw, messy data.
Precisely. It's a sequence. Select, simplify, then forecast.
And this whole 3-step combo, how did it stack up against more standard ways of forecasting?
That's the kicker. They showed it consistently outperforms several standard benchmark models used in economics, things like PCA combined with simple regression, elastic net, dynamic factor models. This 3-step approach just delivered more accurate results.
That's genuinely impressive. It's like they built a better forecasting engine and figured out the best fuel to put in it.
That's a great analogy. Each step adds value.
Okay, so that's world trade. Super interesting. But this nowcasting idea isn't just for global stuff, right? Our second source looked at a specific country, New Zealand's GDP.
That's right. Similar problem, different scale. The Reserve Bank of New Zealand, their central bank, also needs timely info on economic growth, on GDP, but the official numbers lag.
So they face the same rearview mirror issue. What did this research do? Did they try a similar machine learning approach?
They explored a range of machine learning algorithms too, yes. Things like k-nearest neighbor, different types of tree models, lasso, ridge, elastic net, which are types of regression good for lots of variables, support vector machines, even neural networks.
A whole toolkit of ML methods. And they threw New Zealand data at them.
Yeah, they used real-time data vintages from 2009 to 2018, so data as it would have actually been available at the time. And importantly, they tested these ML models against the more traditional statistical models the Reserve Bank actually uses, like factor models and Bayesian VARs.
Okay, so a direct head-to-head, new school ML versus the established techniques. What was the verdict in New Zealand? Another win for machine learning.
Well, here the results were a bit more mixed. The paper actually points out that if you look across all the research trying to use ML for GDP nowcasting, there isn't always a clear consensus that it consistently beats the traditional methods.
Oh, interesting. So it's not a guaranteed slam dunk everywhere.
Apparently not always, or at least the evidence is still building. Some studies find ML works better, others find the traditional approaches hold their own, or are even slightly better sometimes. It might depend on the country, the data, the specific period.
Okay, so more nuance there. What kind of data did they feed into these models for the New Zealand GDP nowcasts? Was it another huge data set?
It was pretty comprehensive, yeah. Around 550 different macroeconomic indicators relevant to New Zealand.
Such as?
Things you'd expect. Business confidence surveys, price indexes, domestic activity indicators like retail sales or construction, trade statistics, of course, and financial market data like interest rates and exchange rates.
A real dashboard of the economy.
Definitely. And they also have to deal with the practical issue that this data comes out at different frequencies, some daily, some monthly, some quarterly. So they had to use specific techniques to transform it all so the models could handle it properly.
Right, you can't just mix apples and oranges, data-wise. Okay, so we've got the World Trade Paper showing strong results for ML, especially that 3-step process. New Zealand showing maybe more mixed results for GDP. What about the third source? That was from the IMF looking at Europe.
Yes, an IMF working paper. They also tackled GDP nowcasting, but across several different European economies. And they compared traditional methods, specifically dynamic factor models or DFMs, against various machine learning algorithms.
DFMs.
Mm-hmm.
Those are kind of designed to pull out underlying trends from lots of data, right?
Exactly. They're a well-established technique for this kind of thing. But what was really interesting is that the IMS study also threw in some non-traditional data.
Oh, yeah. Like what?
Things like Google search trends, maybe tracking searches for unemployment benefits or something, and even data on air quality.
Air quality.
Hmm.
How does that relate to GDP growth?
The theory is, changes in industrial activity or transport might affect air pollution levels pretty quickly. So maybe a drop in pollution could be an early indirect signal of an economic slowdown, or vice versa.
Huh. Okay, that's thinking outside the box.
Hmm.
So IMF compares DFMs, various ML models, uses standard and non-standard data across Europe.
Hmm.
What did they find?
First key finding, most of the methods they tested, both the traditional DFMs and the machine learning ones, did significantly better than a very simple baseline model just predicting based on the previous quarter's growth. So these more sophisticated approaches do add value.
That's good news for forecasters. But was there a single champion? Did one model rule them all in Europe?
No, and this is where it gets really insightful, I think. They found a fascinating pattern. The traditional dynamic factor models often performed best during more normal economic times, periods of relatively stable growth. BUT, many of the machine learning methods were actually better at identifying turning points, things like the start of a recession or a sudden recovery.
So different tools for different conditions, like one's better for cruising altitude, the other's better for navigating turbulence.
That's a perfect way to put it. It suggests that the best approach might even involve combining methods or switching between them depending on what the economy seems to be doing. There wasn't one single model that was the best everywhere, all the time.
That makes a lot of sense intuitively. The economy isn't just one thing. Okay, so these ML models can be powerful, especially for certain situations, but are there any downsides? Practical hurdles?
Yeah, the New Zealand paper touched on this. One issue can be computational cost. Some of these models, especially the complex ones like neural networks or maybe some ensemble methods, can require a lot of computing power and time to train and run.
Not something you can necessarily do on your laptop in 5 minutes.
Probably not for the really heavy-duty ones. And the other point they raised is interpretability, or the black box problem.
Meaning you don't always know why the model made the prediction it did.
Exactly. With a simpler model, you can usually trace the logic, but with some complex ML models, it can be hard to pinpoint which specific inputs or interactions drove the forecast. If it's wrong, it's harder to diagnose why.
Which could be a problem if you need to explain your forecast or build trust in it.
For sure. There's often a trade-off between pure predictive accuracy and how easily you can understand and explain the model's workings.
So it's not just about finding the model with the lowest error rate, necessarily.
Right. Practical considerations matter. But circling back to that first paper on world trade, there are three-step approach, remember. Preselection, factor extraction, then ML regression. That might offer a good balance.
How so?
Well, because it imposes some structure. The preselection and factor extraction steps help you understand which variables and underlying concepts are driving the forecast before you even get to the final ML part. It potentially makes the whole process a bit less black boxy while still leveraging the power of machine learning on the crucial signals.
Okay, that seems like a really promising path forward then. A way to get the benefits of ML without completely losing the plot on why it's working?
Potentially, yes. It seemed very effective for world trade, and the logic could apply elsewhere, too.
All right, so we've covered a lot of ground here, from the challenges of data lags to these sophisticated nowcasting techniques using ML and big data, looking at world trade, New Zealand, Europe. If you had to boil it down, what are the main things you want people to take away from this deep dive?
I think there are a few key things. First, that lag in official economic data is a real problem. But researchers are making huge strides in overcoming it using smarter techniques.
We don't have to just wait anymore.
Right. Second, machine learning, especially some of these regression-based methods combined with intelligent data handling like that three-step process, shows incredible potential for giving us more timely economic insights.
The tools are getting really powerful.
They are. But third, and this is crucial, it's not about finding one magic bullet. Different methods seem to have different strengths. Traditional models might be great for stability, while ML shines at spotting big shifts. Understanding that nuance is key.
Using the right tool for the job, or maybe even a combination of tools.
Exactly. The context matters.
So the quest for a perfect economic crystal ball continues, but it feels like we're getting significantly closer with these approaches. It really makes you think, doesn't it? Here's something to ponder. If businesses, policymakers, even individual investors start having access to much more real-time, accurate economic insights, thanks to this kind of nowcasting, How does that change the game?
Ooh, that's a big question. Does it lead to better decisions, smoother cycles, or maybe faster reactions that create new kinds of volatility?
Right. How might it change investment strategies, government policy responses, maybe even just how you understand the economic world unfolding around you day to day? Something to definitely mull over.
It's a fascinating field, and it's moving fast. What we've talked about today is really just scratching the surface.
Absolutely. For anyone whose interest is piqued, definitely check out the research papers themselves. There's a lot more detail in there. But hopefully this gives you a solid grasp of the cutting edge in economic nowcasting.
Still here? Then you're not just scrolling. You're searching for substance. This isn't just another quant podcast. It's AI translating complexity into clarity, so smart ideas reach smart minds. Like, share, subscribe, join the thinkers, skip the noise. Let's make research accessible, together. Liked how that paper got decoded? We've spent 20+ years turning machine learning and AI into real-world tools, not just slide decks. Whether you want to implement a model, validate research, or build something from scratch, we can help. Explore our showcases to see it in action. Visit our site or contact us directly. Let's turn complex ideas into working intelligence together.